Okay, girls, I wanted to do a better job talking about how you find the direction of the force of the wall on the beam and these kinds of problems. Um, we had a problem over here. Let's see. Nope, we had a problem. In our first problem, we had a beam like this, and you had we put the axis of rotation here. We've got some forces. We said that this torque equals that torque. All right, that's one thing. But then when you had to find the components of the force of the wall on the beam, how did you do it? You know, the Fx and Fy. How come, when does it go up? When does it go down? I want to talk about that. The way that you do that is, what you could do it, is put the pivot in the middle, and then then it becomes clear that if you put the pivot in the middle, these two torques that are left, the torque from the wall and the torque from the tension, have to be equal. Now, this force torques the beam this way. So if you got a torque counterclockwise, you better have a torque clockwise. And so that's why this force from the wall has to be up. All right, you got that? So this is going to torque it this way, that's going to torque it that way, and these, you have to have opposing torques or else this thing is twisting, it's rotating. That's why this force has to go up. I didn't do as good of a job on this one. Let's go over this one. So now just to go over what you did, first you put the axis of rotation here, you've got a torque this way, you've got a torque here, and I think you also had a torque from the beam. These two torques equal that. That's not what I'm talking about, though. When you have to find the x and y component of the force of the wall and the beam, how do you know if it goes up or down? So here's what I wanted to fix, and I didn't do a good job. Once again, all right, so in order to find what the forces wall and the beam is, well, now it'll be convenient to place the axis of rotation here, eliminating this force. Well, it's still a force, but it's not a torque anymore if you put the axis of rotation here. So now you've got two torques. Well, you've got this torque over here. Oops. You got this torque go in this direction. So that means that if you put the axis of rotation here, and we know the beam is not twisting, so the sum of the torques has to equal 0. So how is that beam not rotating? It has to have, so there's a torque going this way. It has to have a force going that way. Why? Because that will torque the beam in the opposite direction. This one goes counterclockwise. Remember, this is counterclockwise. And so this one has to go clockwise. And it's not apparent that it goes clockwise, but if you look at what clockwise is, look, that's clockwise. Something like that would be clockwise. So in order for this thing not to rotate, this wall has to apply a downward force. So the first one was upward, the second one was downward. So the question you're going to have is, well, sometimes it's up and sometimes it's down. How do I do it? Place the axis of rotation. If you want to find that answer, what the wall does on the beam, place the axis of rotation in the middle, eliminating this beam and this weight. I think there was a weight force. Yeah, there is a weight force. So we're eliminating this. These don't provide torques. I keep saying you're limiting the forces. You're limiting the torques is what I should say, because any torque that acts on the axis of rotation is not a torque. So now I can see that this thing is going to torque the beam counterclockwise. So how does the wall prevent it from going counterclockwise? It does a clockwise torque. It's going in this direction. So hopefully that clarifies it. And I apologize. I think it was a little unclear in class. So hopefully that helps you out. Good luck. Bye-bye.